Warm-up number 8, we've got some factoring to do here. So factoring is breaking it apart into a multiplication problem, essentially. Okay, so first thing I'm doing on any factoring problem is seeing if there's a common factor. So I'm thinking, does anything go into x squared, negative 7x, and 6? Nothing does here, okay? So, but I'm always checking for that, or at least keeping it in the back of my mind at the beginning of a problem. So assuming this is factorable, which it is, it's going to factor like this into two binomials that both begin with 1x. Because if you think of FOIL, these would be the firsts, and they would multiply to x squared. So that's all I can really do to multiply to get x squared. Okay, so the trick is figuring out what goes in the back of each parentheses. Many ways to do this. I'm going to use a diamond problem, so I'm going to draw an x like that. I'm going to take the coefficient of the x term and pull the negative with it, but just the number part is the coefficient. That's going to go up here. And then the constant, the number at the end, goes downstairs. Okay? And so what I'm going to do here, this is going to be a little puzzle. I'm looking for two numbers that add to negative 7. And the same two numbers, I'm going to try to do this with integers. The same two integers are going to multiply to 6. Okay? So I usually like to start by thinking about the multiplication side of things. So I'm kind of just brainstorming the ways to multiply to get 6 using integers. So I could do 1 times 6 or 2 times 3. I could also do the double negative versions, because those would multiply to positive 6 as well. Okay? And that's it. Those are the only 4 integer pairs that I can use. So I'm looking for one of those that's going to add up to negative 7. There's only one that does. It's negative 1 and negative 6. It doesn't matter which one you put on the left, which one you put on the right. But these are what goes in the back of my parentheses in either order. But I've got a negative 1 and a negative 6. And there, this is factored. You can always test it out by multiplying it back together. Should get you back where you started if you factored it correctly. Okay? All right. So a couple of things. If there's a coefficient in front of an x squared sign, then especially look to see if there's a common factor. A lot of times there will be, not always. So there is going to be a common factor here, but not here. But that's going to complicate things a little bit. So I'm looking here. Oh, 3 does go into all 3 terms. So factor that out first. So it's kind of like dividing all 3 terms by 3, but we're putting the 3 out there so that we could distribute it back in and it would still be equivalent. What I like to do is think, oh, 3 times something is 3x squared. That would be x squared. 3 times something is negative 18x. That's negative 6x. And 3 times something is 24. That's 8. Okay? So now I've factored the 3 out. And now this trinomial in here looks a lot more like problem number 1. So what I'm going to attempt to do is to factor this further, in the same way that I did on the last problem. Okay, so I'm going to set up a diamond problem again. So I'm not using the negative 18 and the 24 in my diamond problem though, because I'm just factoring the contents of the parentheses. So I'm using the negative 6 up top and the positive 8 down below. Looking for two numbers that add to negative 6. The same two numbers multiply to 8. So I'm going to brainstorm multiplying to get 8. I could do 1 times 8, 2 times 4. You don't necessarily have to write all of these down, but you want to be thinking through these. I mean, you don't have to write a diamond problem at all. This is just a way to organize your thinking through, okay, multiplying to get this, adding to get that. Okay, so I've got a winning pair there. There it is. So that's what goes in the back of these parentheses, and now this is completely factored. Okay, so let's say you had 3x minus 6 times x minus 4. That would be factored, but it wouldn't be completely factored. You need to break it apart as much as you can. Okay, so if there's any more common factors in your answer, then you're not finished yet. Okay, all right, the next problem. I'm looking, oh, there's a 3 in front again. But 3 doesn't go into 10 or 8, so I can't just factor it out the way I did on the last problem. Okay, and again, there's a number of ways to handle a problem like this. I'm going to use a diamond problem again, but since this 3 is here and I can't just factor it out, it's going to be a little bit more complicated. This is what I call a modified diamond problem. So what I'm going to do is take that number and I'm going to multiply it by the constant at the end. Okay, so I'm going to change my trinomial here. So I'm taking the 3 and multiplying it by the -8. So this is just going to be an x squared. Okay, that 3 is going to kind of combine with that number at the end there. And then 3 times -8, so we're multiplying by 3 here, just because that's a 3. And now I've got -24, okay? So now I've got a trinomial that I can factor with a diamond problem. Let's go ahead and do that. Okay, adding to get 10, multiplying to get -24. I was thinking through my options here. And, you know, those are two different options, right? Because they would add to different things. There's a lot of them here. And again, once you find a winning combo, you can stop if you want. You don't need to write them all out. I think I got them all there. Oh, yeah, I got them all, I think. Okay, so looking for a pair that adds up to 10. And it's tempting to use the 4 and the 6, but since one of them's negative, you can't get it to add up to 10. So it's actually going to be that pair, right? Okay, so that means that this is going to factor into x minus 2 times x plus 12. Now here's the problem with this. A lot of people feel like they're done there, but they put their box around their answer. But if you multiply this back together, it would give me this trinomial, not the original trinomial, okay? So there's another step here. So since I changed the original trinomial, I modified this. Now I'm going to have to modify my answer, okay? So those little arrows are just a way for me to indicate, okay, I changed the problem, I got to change my answer back. So what I'm going to do is the opposite of what I did at the beginning here. I multiplied by 3, okay? So now I'm going to do some division by 3. I'm only going to divide the number parts by 3 though, only the constants. I'm not going to divide the x's, okay? So I'm going to write this as, and I'm going to write these as fraction. I'm dividing that -2 by 3, and I'm going to divide the 12 by 3, okay? So next step, I want to simplify these as much as possible. Now, I can't do much with 2/3, but 12 divided by 3 is 4. Okay, but if I had any, say I had 4/6, I would reduce it to 2/3. Okay, but this is already reduced. Now, when you still have a fraction and you can't reduce it any further, what you're going to do is take the denominator of the fraction, take that 3, and pull it out in front of the x. Okay, so I'm pulling that out in front of the x, whoosh, like that. There's a sound effect whoosh, that goes with it. And then the negative just stays there. The 2 is going to fall to the ground because we pulled the 3 out. And boom, there we go, right? So that is our solution. And then you could test it out by foiling it back together. It should give you 3x squared plus 10x minus 8. Okay. All right. So our last problem, it doesn't say factor, it says solve. And notice it's an equation, right? Instead of all the rest of these are expressions. They don't have equal signs. I see a lot of people that are confused about the difference between factoring and solving. Solving means we're finding the x value that works in this equation, that balances this equation. Or sometimes there's multiple x values that work. Okay? So yes, we are going to factor this. So let's factor the trinomial on the left. Okay? So I'll use a diamond problem again. Okay, only really 2 ways to multiply to get -3. And I want the bottom of those, that pair, right? Okay, so this is going to factor into x minus 1 times x plus 3. Okay, now I've got it there, but I'm not finished. Yes, I factored it, but I've not solved it. Now, the main purpose of factoring is now I've got products. So that means when you have two products, two things multiplied together that equals 0, you can use the zero product property because it would have to be 0 times something or something times 0. One of these two pieces has to be 0 to make this equation work. So I can just take this factor and set it equal to 0 and this one and set that equal to 0. Now I can solve both of those and those will be the x values that will work in the original equation. So here I'll add 1 to both sides. Here I'm going to subtract 3 from both sides. So x is going to equal 1 or x is going to equal -3. And you need both of those answers. If you just have one of them, it's not complete, right? And you could try both of these out in the original equation and they will both balance the equation. The whole left side would equal 0 with either one of those. Okay? That's it for this warm-up. See you next time.